Hello everyone, here is Fix Team. I'm Anthony. I'm very happy to meet you here. Today we are showing you the online class. Okay, come on to the class. Hello everyone, today is the class 7. Today we will teach you guys the principle of the camera. Everyone should pay attention in this class. Make the note. Okay, today also have 3 parts of the class. The first is the principle, the theory, and the second is the measurement and repair. And the number 3 is the case, showing to you guys. And for example, in the iPhone 6s, the iPhone 6s have the front camera and the back camera, these two camera. And the camera circuit including the flashlight circuit, because the flashlight circuit also will case the camera maybe have some problem. Okay, now we one circuit by one circuit teach you guys. Okay, first we're talking about the front camera. iPhone 6s used a 5 million pixel camera as the front camera for the face recognition to focus. Normally, we will use this camera when we use the front camera to make a selfie picture or use this camera to make a video. And as you know, the FaceTime camera, the working condition have two. One is power and the second is signal. And the power have 3 kinds power. One is PP 1.8 power and the second is PP 1.2 voltage power. And the number 3 is PP 2.85 voltage power. These 3 level power all is from the PMU. And the width of the signal all is the control signal by the CPU. At first, we see the left side of the FaceTime camera connector. First, we see the 16 and 14, these 2 pins. And the line, the name is MIPI FCAM to APCLK. And MIPI, this name is the MIPI bus. And you can know that as a video line is okay. And the CLK is mean that the clock signal line. And now we see the 20, the 18, the 12, the 10, this 4 9. And as you can see that these 2 9 is data 1 and data 0. This is 2 group of the data 9. Those data signal all is sent by the front camera and go through the arrow and goes to the CPU. Okay, now we see the right side of the this connector. First, we see the 19 and the 15 of the connector. And as you can see that the 19 and 15, these 2 pins all is sent by the CPU. These 2 pins, the 9 is I2C control 9. And the 13, this pin, the line is sent by the CPU. This line is a clock signal. And the 17 is the CPU sent to the camera the shutdown signal, turn off signal. And those is the front camera, the theory, and it is so easy.
Now we are talking about the back camera circuit. For example, the iPhone 6s have a back camera with 12 million of pixels.
And as we know that the working condition of the camera working have 2. One is power and the second is signal. And the first power is 1.8 power and the second is 1.2 voltage. These 2 power all is from the PMU. But the difference in the 3.85 voltage, this is from the U3200, the camera power IC. Okay, now we're talking about the signal part. At the same time, you need to see the certificate, the connector, the left side. And as you can see, the left side of the connector all is the camera to the CPU, the MIPI control bus. And we see the 17 and 19, these 2 pins, the 9. These 2 9 all is the clock signal to the CPU. And the width of those signal all is the data signal. You can see that data 0, data 1, data 2, data 3. After that, we can see the connector, the right side. As you can see, the 22 and 24, these 2 pins, all is the CPU to the connector, the I2C control bus. And you can see that the 28, this pin is the CPU to the camera, the clock signal. And the 13, this pin, the 9 is the CPU to the camera, the shutdown signal, turn off signal. And you can see the 13 to this pin, this 9 is the back camera to the flashlight the driver signal. Okay, now we meaning talking about the flashlight circuit. And for example, in iPhone 6s, the flashlight is two true tone LED. One is warm LED, one is cold LED. And we're talking about the main function of the flashlight. The flashlight, we can use it when we use the back camera to take a picture or video. And the second is we can enable to the flashlight function. And the number 3 is enable the calling recorder. When we setting this, and when someone calling you, and you will see the flashlight is turned on. And in the motherboard have the IC to driver the flashlight. The name is U3300 flashlight driver IC. And first of all, the flashlight want to working normally. The first is this flashlight driver IC should be normally. And the flashlight driver IC want to working normally, he have two working condition. One is power and the second is signal. As you can see the certificate, the power is from the PPBCC min. And as you can see the U3300 this flashlight driver IC, the E3 pin, this pin is the back camera to the flashlight driver IC, the driver signal. Now we see this IC the E2 and D2, these two pin. And this 2.9 is the CPU to this IC, the I2C control bus. And the D3, this pin is from the CPU, the driver signal. And also you can see that the E4, this signal is from the baseband driver signal. And continue go down, you can see the A3, B3, C3, this 9. This 9 is a booster system. As you can see in this line have two capacitor. This two capacitor is booster capacitor. These two capacitor cannot missing, cannot damage, cannot be loose. If we have some problem, we can only change the same one to install it. And now you find the E1 this pin. In this 9 is the flash 9 temperature detect 9. In this 9 you can see that have a resistor. This resistor is R4720. This resistor is temperature detect resistor. This resistor cannot be missing, cannot damage, cannot be loose. If this resistor have some problem, the phone will showing you the high temperature warning. And continue go up, you can see the A4, B4, C4 and D4, this 2.9. This 2.9 all is the flashlight driver signal. 1.9 is for the cold LED and the second is for the warm LED. Okay, this is the theory of the flashlight. Okay, now we meaning talking about the front camera, the FaceTime camera have some problem. How should we test and repair it? When we meet the FaceTime camera have some problem, the first we need to change the FaceTime camera cable. And the second is we need to test the resistance of the FaceTime camera, the connector, the J3100 this connector, to check whether have some line is broken or not. And one of the pin, the resistance is abnormal, we just repair this line is okay. If all the resistance is okay, the first we need to test the power supply of the front camera. And then we need to measure the 1.8 voltage of the I2C is normally or not. Okay, this is the FaceTime camera, how to repair the solution. Okay, now next we're talking about the back camera, how to repair and how to test it. When we meet the back camera have some problem, the first we need to confirm that the FaceTime camera, the front camera is normally or not, because the abnormal FaceTime camera also will case the back camera is not work. When we meet the two camera all is not work, the first we need to repair the FaceTime camera, the front camera first. And how to repair, you just follow the NAS package. And if we confirm that only the back camera is not working, the next step we need to change the back camera first. After we change the back camera is not work, it means that the problem in the motherboard. So we need to test the resistance of the J3200 the back camera connector to see whether there is an abnormal line in this circuit. And if the resistance have some problem, we just repair that line is okay. And all the resistance is normally, we do the next step. We need to test the power supply for the back camera is normally or not. And we also need to test the 1.8 voltage of the I2C is normally or not. If all of those are normally, we need to test the flashlight driver IC. A lot of people don't know that the abnormal flashlight driver IC also will case the back camera is unable. But not install the flashlight driver IC will not affect the back camera normally using. So we can try to remove the flashlight driver IC to have a try to repair. Actually, in the repair, a lot of people test all about the back camera or it's normally, but he don't know these things. Also will case the back camera abnormal. Because in our theory class, you will know that this I2C line sent by the CPU also sent to the flashlight driver IC. So this I2C line is control the back camera and the flashlight in the same time. So if this IC have some problem, also will case the back camera have some problem. So if you know more about the theory of the phone, you will repair it more easy and systemically and professionally. Okay, now we're talking about the flashlight. If we have some problem, how should we to test and repair it? And in the before, we know that have this I2C is control the flashlight and the back camera in the same time. So the first thing when we meet the flashlight is abnormal. The first we need to check whether the back camera is normally or not. If the back camera is not work, the flashlight driver IC will also not work. So the first we need to test the back camera is normally or not. If the back camera is abnormal, we need to repair the back camera first. After that, we need to test the power PPVCC mean. If this power is all normally, we need to change the flashlight driver IC. When we change the flashlight driver IC, we need to remove it. And then after we remove it, we need to test the pin of the pan of this flashlight driver IC to check whether the pin is disconnected from CPU, baseband CPU, and the J3200 connector or not. If the pin in the pan, the resistance have some problem, means this line have some problem. Here is disconnected. So we need to repair this line first. Maybe just the point loose, maybe this just the point missing. We just make a jumper fix this problem. And after that, we need to check whether the 1.8 voltage of the I2C is normally or not. And as you can see in the certificate in this picture, you can see the red line, the PP1VA. This is the power sent to the I2C line. And this 1.8 voltage is sent from the PMU. So the phone is power on, so normally this 1.8 voltage also normally. So we mainly test these two resistors. If these two resistors have some problem, this boost system for the I2C, this power also abnormal. So we need to test this resistor. Because these two resistors is pull up resistor. So if these two resistors have some problem, we just need to change the same resistor. Cannot make a jumper, cannot change another one. You need to use the same type. Okay, now we're going to talking about the case to meaning talking about if you meet the camera have some problem, how should we do? Okay, this is the first case. This is the iPhone 8. The back camera sometimes is good, sometimes is bad. And as we know that if this function sometimes is good, sometimes is bad, it must have some component is loose in the power line or the signal line. So case this function sometimes is good, sometimes is bad. And first we need to take out the motherboard and check the connector J3900, the back camera connector. We can put it under the microscope to see if this connector is loose or not. And after that, we have not found the connector is loose. So we need to clean the groove of the small component around this connector. Why we cannot test the resistance of this connector? Because the function sometimes is good, sometimes is bad. So when we detect the resistance of this connector, maybe the resistance is not right. So actually we clean the groove. We can see that if we clean the groove, the small component is fell off. It means that in the before he had been loose. So we use the quicker A61X hot air gun and use the temperature 300 and the wind air 16 to clean the groove. And the temperature and air is depend by yourself. Because different model hot air gun, the air temperature come out is different. And the quicker A61X, this hot air gun, the air come out is flexible air, flexible wind. So this is more safety And after we handle the glue, we have found out the inductor FL3995 is fell off. And according to the certificate, we can see that the inductor FL3995, the line is 1.8 voltage power supply for the back camera. The power of this line is provided by the PMU, the mean power IC, and through the positive inductor FL3995, and it links to the J3900 back camera connector 10 pin. And this inductor is a positive inductor. If this inductor is damaged, we can make a shock jump in the 2 pin of this inductor pan. After we make a jumper in that place, and we test the resistance value of this connector, the 10 pin again, and the value is normally, and then we install and test. This problem is finished. Okay, see the next case. This is iPhone 8. The back camera cannot be used and the flash cannot be used. And we have been changed the new camera to have a try, and the problem is still. In the before the class, we have been talking about like this. If the back camera cannot use and the flashlight cannot be used. And if the flashlight is not available, the back camera just maybe also will not be available. So we need to check the back camera first. First, we test the resistance of the J3900, the back camera connector, to check whether the line is failed or not. But after the testing, all the resistance is normally. When test the resistance of the connector, it is necessary to test the LDDP line, because the covalent capacitor lands on this circuit. It is difficult to only test the resistance of the connector to test this circuit is normally or not. So we install the back camera and test the resistance of that 2 pin of the covalent capacitor on the LPDP line. During our testing, it is found out that the resistance of the capacitor C3960 is near the CPU. That pin is OL, which should normally be the 632. It means that this line have some problem. And according to the certificate, we can find out this line which is a frequency division multiple access line from the back camera links to the CPU in the LDDP lines. This line is issued by the J3900, the back camera connector, the 22 pin. It links to the CPU after the coupling capacitor C3960. And we have been found out this capacitor has some problem, and we just need to change a new one. Because this is a coupling capacitor, we cannot make a jumper in the pan of it. After we change a new capacitor and test the resistance again, the resistance become to normally. So we install and test, and the problem is finished. Okay, see the next case. This is the iPhone 8 Plus telephoto camera works, but the wing angle camera doesn't work. It means that it failed to open the wide angle lens of the phone, but it can be used normally when switched to the 2x telephoto lens. To repair this problem, you need to confirm that this is the external ACC problem or the motherboard problem. First, we change the new back camera model to test. After test, the problem is still. It's determined that this is the problem in the motherboard. So first, we need to test the resistance of the J3900, the wing angle camera connector, to test whether the line is failed. And after the testing, there is no abnormal resistance. So next, we need to test the voltage. When the 3900 this connector, the pin 1, the voltage have been tested. This voltage is 0 voltage, and normally this voltage should be 2.85 voltage. So due that this line have some problem. And according to the certificate, we can see that the J3900, the pin 1, the circuit is which is a 2.85 voltage power supply line for the wing angle cameras. The power supply from this channel is sent directly from the B3 pin of the U3700 camera power IC to the J3900 pin 1. Because this circuit have a normal resistance but have a abnormal voltage, it's determined that the U3700 the camera power IC has some problem. Generally, we need to change a new camera power IC. But it found that the 7 pin of the J4000 photo lens connector has the 2.85 voltage power supply. So we borrow this to it is okay. So we don't need to change the new camera power IC. From the capacitor C3717, the pin 1, make a jumper to the capacitor C3720 pin 1, and then install and test. This problem is finished. Okay, this is the next case. This is the iPhone 8 Plus. The telephoto lens cannot be used. First thing we need to do also the same. We need to confirm that this is the external ACC problem or a motherboard problem. So we need to change the new camera, have a test. After we change the camera to have a test, the problem is still. So the first, we need to test the resistance of the J4000, the telephoto lens camera connector, and check this line have some problem or not. But after we test the resistance all is normally, so we need to test the voltage. And when we test the voltage, we find that the voltage of the J4000 disconnected the 17 pin was 0, which normally should be the 2.85 voltage. It's determined that this line has some problem. And according to the certificate, we can find out this 17 pin is the 2.85 voltage power supply for the telephoto lens. This load is powered by the output of the U3700 camera power supply IC, the pin B1. Directly links to the J4000, the technical camera connector 17 pin. And the resistance of this line is normally, but no voltage. It's determined that the camera power supply IC have some problem. And during our test, in the other place also have this power. And it seems like the last case. And we just make a jumper from the capacitor C3720, the pin 1, jumper to the C3717 pin 1, and install and test. This problem also finished. Okay, going to the next case. This is the iPhone 8 Plus. The back camera will not turn on, but the flash also will not turn on. To repair this problem, the first we need to confirm that this problem is caused by the external ACC or the motherboard problem. So the first step. The first, we also change the new back camera to have a test. But after we change a new camera for the testing, the problem also still. It means that this is a motherboard problem. And in the class, we have been talking about if the back camera not working and the flashlight must not working. So the first, we need to repair the back camera first. So we just need to focus on the back camera, this circuit. So after that, we need to test the resistance of the J3900 this connector. And after our testing, we found that the resistance of this connector, the 16 pin, is OL, which normally should be the 312. So we confirm that this line have some problem. And as we know, OL is mean that disconnection, open line. So we need to see the certificate. We found out the 16 pin, this circuit is PP 1.8 voltage CAMWIDE which is the 1.8 voltage power supply for the weak angle lens. The power supply of this row is provided by the PMU, the main power IC. It links to the J3900 with angle lens connector 16 pin through the positive inductor FL-V995. After our testing, we found out the inductor FL-V995 is damaged. This inductor is a positive inductor, so we can make a shock jumper in the pan of it. After we make a jumper in the 2 pin of the inductor and the millimeter, so the distance is 361. So it means that this line is become to normal. So we install and test. This problem is finished. Okay, showing you the next case. This is the iPhone X. The front camera will not open and the Face ID is unreliable. If the camera is replaced with a new one, the file will persist and it determined that to be a motherboard problem. Generally, we need to repair the FaceTime camera first because the Face ID unreliable also will may be caused by the FaceTime camera problem. And the first we need to do is we need to test the resistance of the J4200, the front camera connector. When we detect the 14 pin, the resistance value is OL. It means that this line is open line because normally this line the resistance is 395. And according to the certificate, we can find out the 14 pin. This circuit is AP to FCAM shutdown, which is the shutdown signal from the CPU to the FaceTime camera. This signal is sent from the CPU AA135 to the J4200 14 pin through the positive resistor R4211. It's determined that the CPU is disconnected. And the J4530 IR camera, the connector 12 pin is also the shutdown signal sent by the CPU. So we try to take it to test. Make a jumper from the J4530 12 pin to the J4200 14 pin and install and test again. And the FaceTime camera become to normal and the Face ID also normal. This problem is finished. So when you guys meet this problem, it saves us to trouble to remove the CPU. So if you know more about the theory, you will know more about the easy way to repair the phone. Okay, showing you guys the next case. This is the iPhone X. The back camera is unreliable. The back camera of the mobile phone cannot be used, the flash cannot be used, and the Face ID is unreliable. And after the change, the back camera is still fails. To troubleshooting this problem, you should first to finish the photograph problem. The unreliable of the Face ID may be caused by this fail of the back camera. So after that, we need to take out the motherboard and test the resistance of the J3900, the wide angle lines connector. And after our testing, we find out the resistance of the J900, the 8 pin is OL, which normally should be the 329. So this line is disconnection. And according to the certificate, you will see that this is a data line from the CPU to the wide angle lens in the I2C0 group bus. This line is sent from the CPU V13A pins to the J3900 connector, the A pin, through the positive resistor R3901. And the resistance of the measurement, the resistor R3901 near the CPU that ends is 332, which in case that line is anomaly to CPU. And it is enjoyed that the resistor R3901 is damaged. This resistor is a position resistor, so we can make a shock jumper in that 2 pin of the resistor. After we make a jumper in that 2 pin and install and test, the problem all is finished. Okay, showing the next case. This is the iPhone X. Water damage case, no flashlight. And this is the first water damage case. And you need to remember that if you get a water damage machine, you need to first thing need to do is to see, to check, to apparatus, not clean up, because it is hard to change the flashlight. So we first to replace the new housing to test. It found that the problem is still same. It determined that this problem is the motherboard problem. So we layering off the motherboard and repair the flash circuit. When the motherboard is layering, we find that the inductor L4100 above the motherboard had a big water corrosion. And according to the certificate, the inductor L4100 is the setup inductor in the circuit of the flash boost system. The damage of this inductor cannot be shock jumper because this is the booster inductor. So we only use the same type of the inductor can be replaced. After we replace the new inductor RO4100 and install and test the phone, this problem is finished. Okay, showing you the next case. This case is a special case. This problem is linear shooting restart. It means that you put the taking picture button always and the phone will in case restart. Because all the functions of the mobile are normal, in casing that external hardware and the motherboard circuit should be fine. There are 3 reasons for this type of the fail. First is the system problem. Second is the NAND read and write problem. And the 3 is communication fail between the motherboard CPU and the NAND. This solution is put the phone into the DFU model and use the iTunes to upgrade the system to the latest versions, and we test it. After that, the problem is still, so it's not the system problem. Then we replace the new NAND first. We test it after the flash. It found that the problem is still, so not the NAND problem. Finally, the CPU replaced, rebuild, and install again. This problem is finished. It shows that it caused by the CPU loose. Okay, show you guys the iPhone XS mask. The back camera 1X is not available. This mobile phone, the back camera in 1X model cannot be used, but if you change to 2X model, it can be used. And according to this file display, we will know that this problem is the wide angle camera have been problem. So like this, we also do the same. First is change the back camera first, and after that it's not work. It means that this problem is in the motherboard. So we test the motherboard J3900, the wide angle lens connector. After we test the resistance, and we need to check the LDDP bus lines because these have coupling capacitors on this line. It's difficult to test this line, the quality is good or not by the resistance. When we're measuring the resistance of the C3941, this capacitor near the CPU, the millimeter display OL, which normally should be 423. It means that this line disconnect from the CPU. And according to the certificate, we can see that this capacitor is a group of data lines from the wide angle lens to the CPU in the LDDP bus. This signal is sent from the J3900 the pin A through the capacitor C3941 and to CPU C26 this pin. And we remove this capacitor and test the resistance of that end, which is close to the CPU. The millimeter show the resistance value is 408. It means that this line is normally. It's determined that this capacitor is damaged, and this capacitor is the coupling capacitor. The capacitor is damaged. We cannot make a shock jumper independent of it. We only can change this same type coupling capacitor. After we replace the new capacitor and test this capacitor near the CPU that pin, the resistance is come back to normally. So we install and test. This problem is finished. Hello everyone, this is all the information in this video class. I suggest you guys see this video one more time and make more notes, and when you study hard you will get more. Okay, we can come back to our Facebook group, and if you in this class have some question, you can ask and we will give you the answer. Also, you have some problem when you meeting in the repair, you also ask. We also can give you the answer for free. Okay, thank you so much.